Hey class, this is Mr. Roberts coming to you from my beautiful garage. And I just want to quickly go through the answers slash solutions to the study team test for chapter 8. First question, what's the solve for x? It's the absolute value of 4 times x minus 7 equals 7. So when we see this absolute value, right, the distance between some things is 7 units. So we know that that thing is either at -7 or +7. Or thinking about this is looking inside, the thing inside the 4x minus 7 is either -7 or it's +7. So when we solve those, we get x is 0 or x is 7/2. Next question. Solve this absolute value equation. So now we've got this whole thing where we're looking at the absolute value of something is less than 14. So there's always this pattern that you'll see when I have problems that involve absolute value. You can see on the one side here, I've got the absolute value is less than 14. You can see that's always mirrored on one of them, right? So when I break it up, it's always mirrored exactly there. It looks exactly the same, something less than 14. And then on the other side, I'm always going to flip the inequality direction and then take the opposite. So if I'm less than 14 away, right, that means I have to be less than 14 or bigger than -14. So -14 is heading that way. So this is, you're always going to see this pattern, right? Same, keep, flip, opposite. On this one, I solve the two. I get that x is greater than -8/5. On the other side, I've got x is less than 4. It says question 6, but it's only the third question. This one says select all values that satisfy this inequality. So these are ones that make it true, and there were two that we should have selected. The 2, the 7, and the 0. 2, 7, and 0 all make that true. This is the inequality that x values are strictly greater than -2. It does not include the or equals to -2. That's why this is not a solution, because this dot is open, it's not filled in. This next question, it says select all values that do not satisfy this inequality, and there are 3 of them. This inequality is that x's have to be less than 4.5, and those values that do not satisfy that, 5, 7, and 10, are values that don't make that true. Next question. It says find the area of this polygon. Do not include units in your answer, type only the numerical value. So I did write down units squared, but we were asked to not include those. I broke this down this way, and I added the parts. You can see there's a 15, a 16, 15 halves, and 5. Again, I'm making these triangles that have very clear bases that have to be perpendicular to each other. Another option that you could do, let me grab guess I'll grab a blue pen. Another option you had is you could have considered this larger rectangle, maybe if it's even a square, going here and then going along down here, and then going here and going here. And if you would have found the area of this thing, this is 12 minus 2 is 10, and this is 10 by 10, right? That has an area of 100, the entire blue region. From that, I have to subtract some things instead of adding things. So this is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So this is 25. So we could take away that 25. 1, 2, 3, 4, 5, 6, 7, 8, 9 to take away 10. This one right here, we would take away 1, 2, 3, we take away 9. So 100 minus 25 minus 10 minus 9. This one is this would be 2 by 5. This would be 5, take away 5. And on this one, you would be taking away 15 halves. So if you take 100 and subtract 25, subtract 10, subtract 9, subtract 5, subtract 15 halves, you get the same area. So either dividing it up, if you can find the area of the pieces, or finding a bounding rectangle or square and then subtracting things. Let's go on to question 8. It says find the length of segment AI. So AI, when I wrote this slope triangle around it, has a slope of up to over 5, or this bounding right triangle, right? It's a right triangle because vertical and horizontal lines are perpendicular to each other. That has an area of 5 squared, which is 25, plus 2 squared, which is 4. It has a, I'm sorry, not an area. I'm using the Pythagorean theorem. I'm getting the length of this thing is the square root of 29. So root 29 would have been a fine answer, or you could have converted it into a decimal and typed that in as well. So distances involve this Pythagorean theorem. Question 10. Very similar question. It says find the length of segment BG. When I do that, you can see I've got these sides that are 7 by 2. 7 squared is 49. 2 squared is 4. So I'm looking at the square root of 53. I think that is simplified radical form. There's no perfect square factors inside of that. If I go to 11, this one says find the midpoint of BG. So again, we're looking at point B and we're looking at point G, and we're trying to find the point that's exactly midway between those two. And I'm doing this by looking at the average of the x's. So you can see here x is 4 and x is 11. When I add 4 and 11, I get 15, and half of that, half of 15, is 7.5. So the midpoint is on this line where x is 7.5. And then do something similar for the y's. See, y's are at 7 and 5. Well, 7 plus 5 is 12, and half of 12 is 6, so that means that it has to be on this line. And where those two lines meet is exactly at the point 7.5 comma 6. X is 7.5, y is 6. Next, what is the slope of the line that goes through points B and I? Well, from here you can see I have a rise of 7 and a run of 2. If I looked at it this way, I could say, well, I can also say go down 7. I could say go down 7, but then I would be going backwards 2. And if I did that, that's a negative 7 divided by negative 2, which is still positive 7/2. So the slope is still 7/2. 13. What is the slope of the line that is perpendicular to the line that goes through B and D? So you can see I've highlighted the B and D, right? I've got these 2 points. And now that I'm considering points B and point D, I created a slope triangle for that. And you can see from B to D, I went down 3 to the right 2. So the slope of BD is negative 3/2. And to get the slope of a line perpendicular to that, it's it's opposite in sign and reciprocal. So it was negative, it becomes positive. It was 3/2, it becomes 2/3. And then just kind of to convince myself, I did draw an extra little line here that did have a slope of up 2 over 3, and it certainly appears to be right. And then at this point, I could create a square if I wanted. I wasn't asked to do that, so we'll just stop there. All right, continuing on. Our next question asks us to find the equation line that goes through A and I. So you can see I've circled points A and I, and the slope pattern for A through I is up 2 units over 5. It turns out they were nice integer numbers, so 2/5 is the slope. And I can select either one of the points. I used 612, but I could have just as easily decided that I was going to use, for example, I think this is the point 1 comma 10, and I could find the y-intercept just as well either way. I actually used this thing called point slope form. So when you're using the point slope form, oops, let me get rid of this red here. So when you're using the point slope form, the thing is it's always this pattern, y minus the y value that you know. So if I'm looking at what's happening here, big picture, the y value that I know is 12, right? So I've got y minus my known y value. So y subtract this positive 12 equals my slope, right? Slope, which is 2/5, times the quantity of x minus the x value that I know. X minus my x, and my x value that I know is 6. So that is the equation of it in point slope form. I did transform it into slope intercept form. It's fine if you leave the equation like that, but it's a little difficult for me to check, so I do appreciate slope intercept form. So I added 12 to both sides. You can see that. And then I did distribute this 2/5 to the x. So I got 2/5 x. And then 2/5 times -6 is -2/5. The next thing I did is I converted 12 to fifths. So 12 is 60/5. And when I combine -12/5 and +60/5, I got that the equation is y is equal to 2/5 x plus 48/5. And that is the equation in slope-intercept form. Of course, you do not have to do that, right? You could come along and say, look, I'm just going to use what I know. And I know that if I take my y and I subtract m times x, that's going to give me my y-intercept b. So my y value is 12 minus my slope, which is 2/5, times the value of x, which is 6. I'm trying to find out what b is. This becomes what? 12. Oh, yeah, this is going to be 12 minus, this is going to be 12 minus 12/5. So going to fifths is useful still. So 12 is the same thing as 60/5, 60/5. And 60 minus 12, 60/5 minus 12/5 is positive 48/5. So you can see we get the same y-intercept both times. So our y-intercept was at 48/5. All right, next, solve a system of equations. I'm not exactly who it was, but someone I think they were in group 6, maybe period 5. I liked how they processed this problem, so I actually did it the way they did. They did start by multiplying this first equation through by 5, and what that accomplishes, you can see that I've got clearly there is a fact. If I hit every single one of these terms with a factor of 5, like 24 in the numerator times 5 here times 5 here, all of my fractions go away, and that equation it's like 6 times 5 divided by 5 times x becomes 6x, right? 30 divided by 5 is 6. 2y times 5 is 10y. And then 24 times 5 divided by 5 is 24. So that's getting rid of all the fractions. But then what I saw them do next was they multiplied this equation by a half. They multiplied this one by a half. And they multiplied the bottom equation by 1/3. And what that did was, you can see it gave us this 3x and -3x. So multiplying this equation by a half, 6x times a half is 3x, 10y times a half is 5y, and 24 times a half, 24 times 1/2 is 12. And then when I combine them, 5y and 2y is 7y, and 12 and 9 is 21. Divide both sides by 3, and we get that y is 3. Right? 21 divided by 7 is 3. Now that I know that y is 3, I can plug that into the other equation, and actually I used a variation. I used this modified version of the equation, and I put 3 in there for y. 3x plus 15 is 12. 3x is -3. X is -1. And if you take this point, right, x is -1, y is 3, and you plug it in to the original problem, I'm pretty sure that that checks quite nicely. So good job, and thank you for that idea. They asked, is it okay if we multiply this one by a half and this one by 3? Yeah. If you take any of the equations, and if you're multiplying every single term by the same thing, you're going to get an equivalent equation. So good insight. Next problem. We are asked to write the inequality of this graph below, and I can see that it's shaded, below that. So if I can just figure out what this boundary line is, I notice that the boundary is dashed, right? So because it's dashed, it's going to be strictly less than. The slope is -4/6, right? Down 4/6, which reduces to -2/3. And if I pick this bottom point where x is 4 and y is -3, and I plug it in, here's my y, -3, and then minus my slope, which is -2/3, times my x value, which is +4. When I evaluate that, I got exactly -1/3. So I know my y-intercept is -1/3, and my answer is y's are those values that are below, right? All the y's are below the boundary -2/3 x minus 1/3. Question 17 says solve for x, and as I solve this for x, there's two things, right? If I'm considering looking inside, just inside of the inequality, there's two things that x plus 1 can be. That can either equal positive 9 or it can equal negative 9. And you can see I considered both. If it was negative 9, then I subtract 1 from both sides and I get x is negative 10. If it was positive 9, I'm still subtracting 1 from both sides. 9 minus 1 gave me 8. So x is negative 10 or x is 8. Two things. That's the trade-off to get rid of the absolute value. Next, it says find the equation of an exponential curve in the form y equals ab to the x that goes through these 2 points. So one of the things that we can consider is, I mean, we've used systems of equations and I like that technique, but I think I'm kind of enjoying this technique more. So let's look at this. I'm just taking the points I have and putting them in a table of values. So here you can see I've got this point where x is 2 and y is 54. And then later on, I've got this point where x is the number 6 and y is 4,374. So a couple of things, right? I'm starting with this number 54 and I'm multiplying it by a bunch of b's, factors of b, right? What my multiplier is, I'm multiplying it by repeated b's until I get to this number. And the question is, how many b's? Well, if you just take this x value here and you subtract the x value where it starts, you can see that it's 4. So this is 54 times b, 54 times b to the 4th power, 54 times 4 b's becomes 4374. If I divide both sides by 54, I get b to the 4th is that fraction 4374 over 54. And then finally, to get b alone, I know that this is my thinking here. I know that if I have b to the 4th and I raise that to the 1/4 power, that becomes just b, and that's what I want. So I raised the other side also to the 1/4 power. And when I evaluated this with my calculator, it told me that b, my multiplier, is the number 3. Now that I know that b is 3, my multiplier is 3, I can go backwards from the 54, and I could just divide by that twice. 54 divided by 3, and then divide that by 3, and I got my 0th term is 6. So the equation is y is equals to 6 times y equals 6 times 3 to the x. The only thing that would be problematic with this technique is if your first term is really far from the 0th term, it might take a lot of, steps to figure out what your 0 term is. But other than that, that's something to consider, I guess. And there's probably other ways you can handle that too, but that seemed pretty good. And then as a last thing, I always like to just throw 6 on my calculator stack, press enter, and then go times 3 and just verify that it hits these points as a check. All right, let's move on to the next question. Question, what is it, 19? 19 says, solve this equation for x. And you can see that I'm definitely using fraction busters here. And as I look at the things that are going on, I can see this denominator has, I didn't want that pin. This denominator has a 2x, and this one has a 3, this one has an x. So I'm choosing to multiply every single term by 6x. And the reason why is because the number 6 contains both a factor of 2 and a 3, and 6 times x contains a factor of x. So this one value, right, will get rid of all the fractions I see. So I'm literally going through and I'm multiplying 7 times a 6x, the 5 times a 6x, 12 times 6x, and then a 1 times 6x. And when I go through it, I do that, the left-hand side, 7 times 6 is 42. 42 divided by 2 is 21, and there's an x over an x, so this becomes 21. The next thing I've got is 6x times 5 is 30x, and 30x divided by 3 gives me 10x. So I'm looking up here when I'm saying these things. The next one is 6 times 12. So that's 6 times 12 or 72x, but there is an x divided by an x, so that's gone, and I'm left with just 72. And then the last one I have is just 1 times 6x, which gives me 6x. I guess next, what did I do? I could take away 6 times x from both sides, and then subtract 21 from each side, and then getting that x was 51 fourths. I did put a question mark here. I did not actually check that, so if you check that and I'm wrong, let me know that I was wrong in the video. I'd be happy to give you extra credit, but I don't think I ran that through my calculator as a check. Moving on to question 20. So the first thing I did is I rewrote this left-hand side, and I didn't use an area model. I just multiplied each of the terms by each of the terms. So when I'm doing this, I did multiply the x times the 2x, which gave me 2x squared. And there is this, then there's this 2x times 3, which gives me the 6x. And then there's the 3 times the negative 3 times the negative 1 is giving me a negative 3, and then there is this 1 times x, which gives me a negative x. So if that seems confusing, feel free to use a generic area model and do that multiplication. But I did subtract 2x squared from both sides because I had that on both sides. And then I also combined the 6x minus x. 6 of them minus 1 of them gives me just 5 times x. So 5x minus 3 is 22. 5x is 25. X has to be the number 5. And if you plug that in, it should definitely make both sides of that equation the same. 21. Simplify this monomial. So this part, there's really nothing to do with it. So I just rewrote that and left it alone. But if I have this, if I have y to the negative 4th over y, that is exactly 1 over y to the 5th. My justification for that is I can multiply both the top and bottom by y to the 4th times y to the 4th. And when I do that in the numerator, I get just the number 1. That's literally y to the 0 power. Y to the 0 power is equal to 1. And you can see now I've got 1 and 4 more factors of y in the bottom. So there's 5 factors of y in the bottom. And then just putting that all together, I get 3x y to the 8th, which was one of the choices. 3x y to the 8th. 22. This one. 6 divided by 2 is 3, so I've got this 3. And then this x to the 3rd, I didn't write this, but my thought is literally I'm multiplying by x to the 5th in both the top and bottom. That will give me an x to the 8th in the top, and it literally, these two just become the number 1 in the denominator. So I've got 3x to the 8th times y to the 3rd, which is one of our choices. And 20, oh, that was the last problem that appeared. 22 was the last question. I do have a couple extra ones that I discussed in class. I'm not going to record them here. So if you're watching this, we did talk about a few other things in class. So if you've got extra questions, try and show up early tomorrow or see me at lunch or something so we can discuss those. But we will be taking the individual test on Tuesday. Have a great evening. Looking forward to seeing you in class. Goodbye.